It is 3 in the morning. The house is completely dark. The kind of silence that only exists between midnight and dawn, when the world outside has stopped moving and even the air seems to be holding still. You are not asleep, but you are not fully awake either. You are somewhere in between, drifting when it happens. Your baby starts laughing, not whimpering, not crying, not making the soft searching sounds that mean they're hungry or uncomfortable. Laughing. That full, helpless, belly-deep laugh, the one that normally takes you 15 minutes of peekaboo and 2 rounds of funny faces to produce. You are suddenly very awake. You sit up. You look over. Your baby is staring at the corner of the ceiling, grinning at it, reaching toward it with one small hand, as if greeting someone standing there, completely captivated by a patch of wall that contains, as far as you can tell, absolutely nothing. You look at the corner. You look back at your baby. You look at the corner again. There is nothing there. A right angle of painted drywall, maybe a faint shadow, maybe the residual glow of a streetlight. Nothing that should, by any reasonable measure, be that funny. Every parent who has ever experienced this moment follows the same sequence. First, amusement, then confusion, then a creeping, irrational unease that they will later feel slightly embarrassed about. They nudge their partner. They whisper, "Do you see that? Is someone there?" They lie awake after the baby finally settles, listening to the silence, thinking thoughts they won't admit to in daylight. By morning, most of them have typed something into a search bar, and the results they find paranormal forums, spiritual communities, well-meaning Reddit threads full of anecdotes about ancestors and angels do almost nothing to explain what actually happened. Because the actual explanation has nothing to do with the supernatural. It has to do with neuroscience, and it is, in its own way, far more extraordinary than any ghost story. The standard reassurance from relatives and pediatricians alike tends to go something like this. Babies are essentially random at this age. Their brains are undeveloped. They react to light, to air movement, to sounds below your hearing range. They are not processing anything with intention or meaning. Don't read too much into it. It means nothing. This explanation is comfortable. It requires no revision of your assumptions. It lets you go back to sleep. It is also, the research is now clear, fundamentally wrong. To understand why the "it's just random" explanation fails, you have to start with a number. 100 billion. That is the approximate number of neurons present in a newborn baby's brain at the moment of birth. It is also, give or take, the number of neurons in your brain right now as a fully developed adult. The infant brain does not begin small and grow toward complexity. It begins with the full complement of raw material already in place. What it lacks is not capacity. What it lacks is connectivity. The neurons are there. The roads between them are not. And that distinction changes everything about how we should think about what is happening inside an infant's skull. The process of building those connections, of wiring one neuron to another, of establishing the pathways that will eventually carry thought and memory and language and feeling, is driven almost entirely by experience. Every sensory input the baby receives is not just perceived, it is incorporated. It reshapes the brain at a structural level, physically altering which neurons connect to which, how strongly, and how quickly. This means that when your baby lies in their crib at 3 in the morning, staring at a corner and laughing, their brain is not idling. It is not doing nothing. It is operating at a level of processing intensity that you, as an adult, will never experience again. The mature brain has already built its roads. It travels the established routes. The infant brain is laying new asphalt in every waking moment, and the activity that looks like random amusement is, neurologically speaking, construction work. The random baby theory also collapses when you examine what babies are actually looking at. For decades, the prevailing medical assumption was that infant vision was severely limited, that the world appeared to newborns as a vague, indistinct blur that only gradually sharpened over the first year of life. This assumption shaped how we talked about and responded to infant behavior for generations. Modern eye-tracking technology dismantled it. Using the same non-invasive gaze-mapping tools developed to study how adults read and navigate screens, researchers were able to follow precisely where infants directed their attention and for how long, and in what sequence. What emerged was not the picture of a brain receiving vague impressions. It was the picture of a brain with highly specific, highly active visual priorities. A newborn's visual system is not a lower resolution version of yours. It is a differently calibrated version. It is tuned, with remarkable precision, for three things in particular: high contrast edges, movement at the periphery of the visual field, and faces. Not because faces happen to be nearby, because the detection of faces is hardwired into the human brain before the first breath is taken. This is the moment the comfortable theory fails completely. A brain with 100 billion neurons, running at full construction intensity, actively selecting specific features of its environment to process with dedicated neural hardware that is not a system doing nothing. That is a system doing something very particular. And when you understand what that something is, the 3 in the morning laughter stops being mysterious and starts being one of the most coherent things you have ever witnessed. That corner of the ceiling your baby finds so compelling is not arbitrary. It is, from the perspective of your baby's visual system, one of the most interesting objects in the room. The right angle where 2 walls meet the ceiling produces one of the highest contrast edges in any standard domestic environment. Your baby's visual cortex, calibrated to detect exactly this type of feature, registers it with something close to enthusiasm, but the edge is just the entry point. What happens next is where it gets genuinely strange. Research published in the journal Current Biology found that infants as young as 4 months old are not simply reacting to what they see. They are doing something considerably more sophisticated. They are generating internal predictive models of what they expect to happen next. And they are tracking, in real time, whether the world matches those expectations. This is called predictive visual processing. It is a core function of the adult brain. It is the reason you are not startled every time a car drives past your window. Your brain predicted it would, and it did. The surprise is not in confirmation. The surprise is in violation. Your baby is running this same process. They are not staring at the corner passively. They are making active predictions about it. And when something in that corner, a shadow that shifts a few degrees as a cloud moves past the streetlight, the faint disturbance of air from a vent, the natural flicker of any light source matches or violates their prediction in a way that reads as novel and non-threatening, they laugh. That laughter is not random delight. It is a cognitive response. It is your baby's brain signaling, model updated. Something new and interesting just entered my understanding of how the world works. But why do so many parents report that it seems like their baby is laughing at a face? Why is it so often a particular shadow, a specific pattern of light on the ceiling that produces the biggest reactions? The answer is one of the most remarkable facts in all of cognitive neuroscience. The human brain contains a dedicated neural region in the right temporal lobe called the fusiform face area. Its sole function is the detection and processing of faces. It operates faster than conscious thought adults can identify a face in approximately 130 milliseconds, faster than the time it takes to register a single written word. And it does not require an actual face to activate. It requires only the suggestion of two roughly circular features positioned above a single feature is sufficient. This is the same mechanism that makes you see a face in the pattern of a wood grain, in the front end of a car, in a pair of electrical outlets on a white wall. In infants, this system is not just present, it is hyperactive. Research from Harvard's Infant Cognition Lab confirmed that newborns within hours of birth, before any meaningful visual experience could have shaped their preferences, already show a clear bias toward face-like arrangements over non-face arrangements. The preference is not learned. It is present from the beginning, wired into the brain before the first image is ever processed. In a baby whose fusiform face area is still being calibrated, still establishing the parameters of what qualifies as a face and what does not, the activation threshold is dramatically lower than in an adult. That shadow in the corner, with its particular contrast and shape, that pattern of light cast by a passing car, the texture of a stippled ceiling viewed from below. To a 3-month-old brain, these patterns do not look like nothing. They look, with reasonable neurological certainty, like someone. Your baby is not laughing at an empty room. They are laughing at a friend their brain has assembled from shadow and contrast, and the ancient neural machinery that has been finding faces in the dark since long before our species had language. And here is what makes this more than just interesting. Research from Yale University's Mind and Development Lab found that infants who are most active in their face detection, who laugh most readily at shadows and textures and ambiguous patterns, show faster development in social cognition and language acquisition in the following months. The overdetection is not confusion, it is practice. Every phantom face is a training repetition, building and refining the neural circuitry that will, in 6 months' time, allow them to read a real face with extraordinary precision. Your baby is not confused. Your baby is doing exactly what a well-functioning, developing brain is supposed to do. Now to the question of timing. Because the fact that this happens at 3 a.m. is not a coincidence. It is not because nothing else is happening, and so your baby has turned their attention to the ceiling. The timing is specific, it is consistent, and the reason for it is one of the most extraordinary things currently happening inside your child's body. Adults spend approximately 20% of their sleep time in REM, rapid eye movement sleep, the phase associated with vivid dreaming, emotional processing, and the consolidation of memory. Newborns spend up to 50% of their sleep in REM. That alone would be remarkable. But there is more. Sleep researchers using portable EEG technology to map electrical brain activity in infants have identified a specific peak period of REM density that occurs in babies between 3 and 5 months of age. That peak runs, in most infants, from approximately 2 to 4 in the morning. During this window, the infant brain is engaged in what neuroscientists call spontaneous neural activation. The brain is generating its own patterns of electrical activity, not in response to any external stimulus, but from within, as part of the ongoing process of building and testing its own architecture. It is the brain running diagnostics on itself while simultaneously laying new connections. In adults, this internally generated activity produces the imagery of dreams, filtered through a mature cortex that keeps the experience cleanly contained within sleep. In infants, the cortex is still forming. The connections between the visual cortex and the prefrontal cortex, the region responsible for filtering and regulating incoming signals, are not yet strong enough to maintain that separation. The result is something that has no direct equivalent in adult experience. The internally generated neural patterns bleed into waking perception. The brain's own spontaneous activity gets overlaid onto whatever the baby is actually looking at. The corner of the ceiling is there, but so are the patterns the brain is generating from inside. Both streams run through the same visual processing system simultaneously, indistinguishable from each other. Your baby at 3 in the morning is not fully asleep. They are not fully awake. They are in a liminal neurological state, experiencing both the room and the activity of their own mind, projected together on the same surface, without the ability to separate one from the other. The closest approximation in adult experience is the hypnagogic state, that brief window as you fall asleep when vivid imagery appears against the backdrop of the real room around you. Most adults experience this for seconds before sleep takes over. Your 4-month-old is living in that state for extended stretches of the night. They are laughing because what their brain is generating and projecting onto the walls of the room contains exactly what their neural circuitry finds most rewarding: faces, movement, novelty, contrast. The room becomes a screen, and the film playing on it was written and directed by the brain watching it. There is one more dimension to this that reaches beyond the baby and into the loop that forms between the infant and the watching adult. When your baby laughs, truly laughs, that full, helpless laugh at something invisible, you feel something. A warmth, a pull toward them that is difficult to locate or name. That response is not simply love, though love is present. It is neurochemistry. Your mirror neurons are activating. Mirror neurons fire both when you perform an action and when you observe someone else performing the same action. They are the biological substrate of empathy, of the capacity to feel what another person is feeling from the outside. When you watch someone genuinely laugh, your brain rehearses laughter. Research from the Max Planck Institute for Human Cognitive and Brain Sciences found that infant laughter activates the orbitofrontal cortex in adult listeners, the region associated with reward processing, more strongly than the laughter of other adults does. Your brain is specifically and precisely calibrated to find your baby's laugh more rewarding than almost any other sound you will hear in your lifetime. This creates a loop. Your baby laughs at the face in the shadows. Your mirror neurons fire. You feel the pull. You lean forward. Your own face opens into warmth. Your baby's face detection system, running at maximum sensitivity, reads your expression and registers. This is good. They laugh harder. You feel more. The loop tightens. And inside that loop, something of profound importance is taking place. Your baby is learning, for the very first time, that their internal experience has weight in the external world. That the things happening inside them, the phantom faces, the neural projections, the private fireworks of a forming mind, matter to someone outside them, that the world responds. That is not a small thing. That is the first brick in the architecture of selfhood. Your baby is not just laughing at something on the ceiling. Your baby is discovering, one laugh at a time, that they exist. The corner laughing is normal. More than that, it is a sign that things are working as they should. If your baby laughs at shadows and stares at ceiling textures, and reaches toward walls with the focused delight of someone greeting an old friend. You are watching a healthy, developing brain doing exactly what a healthy, developing brain is supposed to do. There is nothing to fix and nothing to worry about. But there is something to watch for, and understanding the developmental trajectory of this behavior is what allows you to use it as information rather than simply charming noise. Between approximately 4 and 8 months of age, a specific transition is expected to occur in how an infant generates laughter. In the early months, laughter is predominantly triggered by self-generated visual stimulation, the phantom faces, the high contrast edges, the spontaneous neural activity of those pre-dawn peak REM periods. This is developmentally appropriate. It reflects a brain in the active, early stages of building its visual and social processing systems. As the brain matures, as the cortex thickens, and the connections between regions strengthen, the liminal state that allows internally generated activity to bleed into waking perception gradually resolves. The visual cortex and the prefrontal cortex establish a cleaner working relationship, and the primary trigger for infant laughter should shift from self-generated visual novelty toward shared social interaction. Peekaboo, tickling, the exaggerated expressions on a caregiver's face, the back and forth of vocal exchange. This is the milestone, the shift from laughing at corners to laughing at people. If that shift occurs, it is a meaningful developmental signal. If it does not, if a baby in this window shows a plateau in social laughter while continuing to laugh predominantly at objects and patterns, or shows a regression away from social responsiveness, developmental pediatricians describe this as a soft, early indicator worth raising with a doctor. Not a diagnosis, not a cause for alarm, a data point, a conversation to have. Your baby cannot tell you what they are experiencing. They have no language for it. Behavior is the only channel through which they can communicate what is happening inside them, and knowing which behavioral shifts carry developmental significance is not anxious over monitoring. It is informed attention. The science gives you a map. The milestone is marked on it clearly. You do not need to stare at the ceiling yourself, wondering. You simply need to watch for when your baby stops laughing at it and starts laughing at you instead. So the next time you wake at 3 in the morning to the sound of laughter coming from the crib, that full, inexplicable, directed at nothing laugh, you don't have to reach for your phone and open a paranormal forum. You know what is happening. Your baby's visual system is encountering a high contrast edge for what feels, neurologically, like the very first time. Their fusiform face area, ancient and hyperactive and magnificently overtuned, is assembling a friend out of shadow and ceiling texture and the residual light from the street outside. Their dreaming mind is bleeding into their waking perception, projecting its own private imagery onto the dark walls of the room. And their brain, 100 billion neurons, laying roads in every direction at a pace that will never come again, is laughing because something unexpected and wonderful just updated its model of the world. You are not watching something eerie. You are not watching something meaningless. You are watching a consciousness come online. You are watching a mind encounter reality and find it, against all odds, delightful. You are present for the moment your child discovers that the world is interesting, that it responds, that they are in it. That is not something most people ever get to witness. It happens in the dark, in the quiet hours, in a room that appears to contain nothing remarkable. And it is, if you know what you are looking at, one of the most extraordinary processes in the known universe. Stare back at the corner for a moment. You won't see what they see, but now you know what's there. If your baby has done this, laughed at nothing, reached for something invisible, found a friend in a shadow at 3 in the morning, leave a comment. Tell me how old they were. Tell me what corner they loved, because I want to know. And if you want to understand what happens when you leave the room and come back, why your baby sometimes cries harder the moment they see your face after you have been gone, not because they are angry, not because they are being dramatic, but because of something happening deep inside the attachment system that most parents completely misread. That is where we are going next. And once you understand it, you will never feel guilty about leaving again.